going. What I've done the sum of all the squares of a number. So this just run the section, go over to Matlab, and it's sum of squares gives me that. If I just want to do sum of all the x's, of course that's n times n plus 1 divided by 2, which is 50. It should work out to be 50-50, or 5, yeah, 50-50. So there's a function for you to review. Right here, I wanted to go through a few of the, just review you on the plot stuff. So this is the section. It's going to create the sines and cosines. It's going to plot them. It's going to put labels and titles on your plots. It's going to make a square axis. And these down here are some new things too about printing your figures. And we'll see what they do. And I'm just going to make sure to get rid of these so you can see what's going on. Okay, so getting rid of these two things. And there. The next section has to do with holding. I'll get to that. So this is just a review of the plot, some of the things you can add to the plots and change and modify and stuff like that. You can save your figure files. So let me run this section. It creates two vectors, it plots them. So running this section creates a sign. It also creates two files. This is a file Matlab reads. So it creates a second figure. It's identical to the first one. I've just saved the first figure. That's all I've done. It's just a save command. The square axis, by the way, you'll notice the plot area is square. That's what that axis square does. This command right here. Print will save it out as a postscript. It's trying to print to a printer. I saved it to a file which I cannot open. So this, yeah, you'll notice it's nonsense. It's craziness. This is a postscript printer file so that it, well, anyway, impossible to read. Send it to the printer, in other words. If I did print without a file name, all it would do is take that figure and send it to the back. So let's try that. I'm going to go ahead and do that. So the printer in the back of the room should start crank right up when I run this section now. So there it goes. So there it comes. Now, next step here is this hold on. This is to overlay the plot. So I'm going to get, there's figure 1. There we go. You've saved it as a fig file, by the way. This one does open up. You can view it in Matlab normally. You can't view it in, you can't view it, say, in a photo editor or something like that. But you can view it in Matlab. The save command also lets you, where is it? There it is. This save command, print command, excuse me. You can specify a JPEG format and things like that. So you can save files as JPEGs and so forth in using one of these two commands right here. There's also something called image write, IMG write, which you can use. Let's just look at that. Or I think it's IM write. It's not. Oops. Oh, help. I need to do help IM write, not just IM write. Okay. So, yeah, here's, you can use IM write to save it as a JPEG, a PNG. PNG is pretty good. It's fully indexed. TIFF, GIF, things that other programs can work with. So you can send images, your figures, to files and so forth. Okay. So now holding. Did I already execute the hold on business? I have not. I haven't executed this section. So basically, I'm not going to go away from figure 1. Basically, whatever figure I'm on, it stays on it. And then it just adds another line to it. So let's run this section, see what happens. And take a look at the figure. Oops. Oh, do you guys know what I did? I'll show you. Okay. So I goofed. So here's the, oops, and I sent another print. I want to comment this guy out. I don't want to do this again. So I've recreated figure 1 with my previous commands. Here's what I did wrong here. I forgot I was in degrees. Cosine in degrees, right here. Run it, and it ought to overlay on figure 1 just perfectly now. This is the sine, and the second one's the cosine. Okay, display. This is a way you can put additional information into your files. So I'm going to, and also I wanted to show how this fix and floor stuff works. So I'm displaying the command before I actually execute it. Lots of displays before I execute the command. Here's a date command. I'm going to look at hours, minutes, seconds also. So that's what this section does. And let's go look at the command window. So first display, my name is Jim. This is the effect of fix 1.5, floor 1.5. Fix just goes towards 0. So the fix command goes towards 0. So fix above, for positive integers, fix and floor are the same thing, but not for negatives, you'll notice. Fix goes closer to 0, so fix negative 1.5 becomes negative 1. Floor is the lower number, which is negative 2. Rounding, answer rounds to 2. Ceiling just goes up. Of course, if you round 1.4, you'll get 1. If you do ceiling 1.4, you'll get 2. So that's how floor and ceiling work. And fix and round. Here's the date. When I execute the date command, get this. Clock gives me a vector of 6 numbers. Hour is the this number here. It's 2, minute 13, seconds pretty close to 43, and it's got lots of fractions and stuff. Okay, next. Number to string. You might need this sometime. So I'm going to run this section. So I'm going to create a string. You'll notice the strings display differently. The number, I'm going to convert that string back to a number now. So display. So W is number to string, makes W a string. Now I'm converting back. Now it makes W a number, and I can I can multiply that number by 2. So I've converted back to a number. It displays differently. If W is a string, it looks like this. If it's a number, it looks like this. And I can multiply the number. I can't multiply the string. String cat. It basically puts strings together. The square brackets should do the same thing. I found the square brackets to be a little unreliable. So I like to use the function string cat. S-T-R-C-A-T. String concatenation. It's kind of like concatenate in Excel. Some of the things are the same. Last week we dealt with matrices. So we're ready to go to matrices here. So we've talked about matrix multiplication. I just wanted to show you a few extra things. Ones creates all matrices of 1. Zeros creates all matrices of zeros. Identity. And SPY tells you where numbers are not 0. So if you run SPY, it'll put a star where there's a non-zero number and a blank everywhere else. So if I run this section, we'll see, oops, I should have just run the section. I shouldn't have gone to the next section. Oop, I'm in the wrong section. There it is. Run this section here. So So I've made a 3 by 4 ones matrix. Size, the size of a matrix. I also got the size. It is 3 rows, 4 columns. 3 rows, 4 columns. Zeros, 3 comma 4. Matrix of all zeros. Matrix of ones down the diagonal, zeros everywhere else. And that's what I does. And SPI now tells you where the non-zero elements are. It shows up in the figure. So this last one, you have a 3 by 3 matrix with ones down the diagonal. So at 1, 1, you have a non-zero, 2, 2, you have a non-zero, 3, 3, you have a non-zero, 0 everywhere else. So SPI lets you get a quick kind of visual feel of what your matrix is doing. Okay. Now, the new stuff. I'm going to create an anonymous function. Here's your anonymous function. I'm going to call it ballistic, and I'm going to set initial velocity as 10 meters a second, initial position -10, and of course, those of you in physics would recognize this as the height of an object given time, given original velocities and original distances, and time. Then I created I created the anonymous function. I created a vector. I used the anonymous function next, and then I plotted it. So let's run this section. And this just says what I'm doing. The figure ought to tell me. There it is. So you can create anonymous functions. I usually like to create a function file. I'm not terribly fond of anonymous functions or inline functions, both of which you can do in Matlab. I think it's better just to create a file, put your function name, be organized, and do things that way. But you can, it's possible to do it, just not very recommended. Okay. Next new topic, exporting data. The easiest thing to do is just, if you go up to the menu in the workspace, you can just hit Save. You can also do Save from here. What it will do, and it will create what's called a .mat file. And we ought to be able to see it. I'm pretty sure I have to give it a file name. I don't think I can do it just all by itself if I hit save, unless it might do it. Let's take a look, see what happens. Okay, there we go. So I did not give it a file name, and it saves all my data in this file. So it automatically created a default file name for me. And if I can clear out my data, I can use the drop-down menu, clear workspace, right here. I could have done the same thing here, by the way. If I do this, I think it'll ask me for a file name. So I'll call it MATLAB 2, all my files 2. You can also save. You can also specify a file name. Let's see. You can always hit, by the way, help here. You can type on the command line. You can type this. You can save everything in your specified file name. You can save specific variables. You don't have to save all variables. If you right-click on the variable, you can save that variable through the GUI.